Hello and welcome. We are Group 1, the RStudents. Today we are excited to present our project titled Visualizing Global Renewable Energy Transition Progress Towards a Sustainable Future. Our project addresses an urgent issue transition to renewable energy in the fight against climate change. Despite global efforts, progress has been inconsistent over the past decades, and stakeholders lack clear, actionable insights. Through this video, we'll explain the problem, why it matters, and how we tackled it. We will also walk through the interactive visualization tool, share the scientific reasoning behind its design, and highlight its potential impact. Let's begin by identifying the problem. Climate change and global warming are intensifying due to excessive reliance on fossil fuels. Transition to renewable energy is crucial, but many countries struggle to measure progress and identify gaps in their energy policies. Why is this a problem? Because without clear data, policymakers cannot act effectively, educators cannot teach accurately, and citizens cannot advocate for change. This lack of accessible interactive tools hinders our collective ability to combat climate change. Who is this problem for? Primarily for educators and students who need real world data to engage in meaningful learning. It's also a problem for policymakers who must benchmark their progress and for the general public who deserve clear insights into their country's energy landscape. Why is it important? Well, because every nation's energy choices impact global warming. We cannot address this issue without clear, actionable data showing where we stand and where we need to improve. And why hasn't this been solved yet? This is because existing tools are either static or overly technical or scattered across multiple sources. This makes it difficult for non experts to interpret the data and act on it. Our project fills this critical gap. Our solution is an interactive visualization tool designed to make global energy data accessible and actionable for everyone. What impact will this have? Well, for policymakers, it highlights where they need to focus their efforts. For educators, it brings in real world data into the classroom. For the public, it provides a clear picture of global progress, sparking informed discussions and advocacy for change. Let me demonstrate how it works. So this is the tool, and it bridges the gap between raw data and actionable insights, empowering everyone to contribute to a greener future. Our visualization follows a martini glass narrative structure, starting with an author-driven story, and that broadens into a reader-driven exploration. Um, we begin with a guided insight about global energy trends that highlights that allows users to freely explore the data through interactive features. Let's demonstrate some of our interactive features. The world map uses color saturations to provide energy generation intensity. Hovering over any country reveals its rank and percentage of global energy generation. The timeline slider bar enables users to navigate with smooth transitions. The bubble chart uses size as a magnitude channel to represent regional energy share. Our data consists of spatial data like country boundaries, quantitative data like energy generation, as well as categorical attributes like energy types, and ordinal data like the country rankings we show here. We carefully selected visual channels based on effectiveness principles like size for quantitative values, color hue for different categorical variables, saturation for ordered magnitude, and interactive highlight for selection. Our design leverages several Gestalt principles, continuity in our timeline, showing clean energy goals, enclosure through our hover functionality that creates a box around a selected country. We implemented multiple interaction methods like selection through hovering, navigation via the timeline, filtering by energy types, as well as aggregation in regional views. And we could also filter like this. Let's take a deep dive into the scientific process behind our project. Developing this solution required rigorous research, iterative design, and critical thinking to ensure it addressed the problem effectively and meaningfully. We began with an in-depth background research to understand the problem space. This included analyzing reports from International Renewable Energy Agency, or IRENA for short, and studying global energy trends over the past 2 decades. Our primary data set included energy capacity metrics across 235 countries categorized into 12 broad technologies such as solar, wind, and fossil fuels, and 23 specific energy types like natural gas and coal. We also reviewed academic literature and data on global warming to understand world energy usage and goals to deepen our understanding. Next, we engage in user research to identify the targets and needs of our target audience. Educators, policymakers, and students provided insights into the challenges they face when interpreting global energy data. They helped us define our tool's goals, interactivity, clarity, and accessibility. Using this foundation, we adopted an iterative design process. We started with paper prototypes, progressed to digital mockups, and finally implemented our interactive visualization using tools like Tableau, JavaScript, and R. We considered several alternative approaches before finalizing our design. Initially, we thought of using static charts and reports. However, our user feedback, which was basically discussions during class and tutorials, we found that interactivity was a critical feature for engaging users and enabling detailed exploration. A static report simply couldn't convey the same depth of information or flexibility as an interactive tool. We also debated focusing solely on per capita energy consumption instead of including absolute values. While per capita metrics are important, we realized that a comprehensive view of both absolute and relative metrics was necessary to understand global energy trends. Furthermore, we chose to prioritize a graphical visualization like the world map because it allows for users to intuitively connect spatial and temporal patterns, something tabular or linear visualizations could not achieve as effectively. Our data comes from IRENA's Renewable Capacity Statistics, a well documented authoritative source that offers granular insights into renewable energy transitions worldwide. This data includes metrics like energy capacity in megawatts and energy generation in gigawatts and sustainability scores. For our analysis, we chose to focus on three main tasks: identifying trends, comparing countries, and exploring details. To achieve this, we incorporated multiple views: a world map for spatial trends, a timeline slider for temporal trends, and bubble charts, bar charts, as well as line plots for comparative insights. Our design choices followed principles of effective data visualization. For example, we used distinct hues to represent different energy types, such as green for renewable and gray for fossil fuels. Saturation was used to indicate intensity, such as proportion of renewable energy in a country. We also incorporated animations in our timeline slider to make transitions smooth, helping users identify trends more intuitively. Our design effectively uses both identity and magnitude channels and made sure there was a level of interaction which allowed users to explore the data further so that more questions could be answered. We followed an iterative design process grounded in users' feedback and data visualization theory. After our initial brainstorming, we created rough sketches and wireframes, which were then reviewed by our target audience. During early tests, educators appreciated the tree map, but found it a bit complex and had trouble reading the full labels. Based on this feedback, we switched from a tree map design, which initially used squares for region, to a bubble chart. This change effectively made labels easier to read and highlighted proportional differences more effectively. Another improvement came from testing animations. Users mentioned that smooth transitions between years made it simpler to grasp temporal track trends and track patterns over time. To address this, we replaced the drop-down menu for selecting years with this slider. This made navigating and interpreting the data more intuitive while keeping the transition seamless and space efficient. It also reduced the effort needed to explore different years' data. Our project is grounded in science because it integrates reliable data, follows evidence-based visualization principles, and employs a systematic approach to problem solving. Every design decision was guided by a theory and validated through testing. We based our visualization on equalities from Alberto Cairo's outlines in The Truthful Art: Truthfulness, Functionality, and Clarity. Our choices to use a world map wasn't arbitrary. It was supported by research showing the effectiveness of spatial visualizations for geographic data. We also applied critical thinking by exploring and rejecting alternative designs. For instance, we considered using a map with only outlined and colored regions, but found it lacked depth needed to highlight country and technological trends simultaneously. We critically evaluated alternative analysis, such as focusing only on renewable energy or excluding countries with incomplete data. Ultimately, we chose to include all energy types by creating groups and technologies titled Other to provide a more comprehensive perspective. Furthermore, to address the lack of incomplete data, we decided to gray out the countries for which we lack data and include color for only the countries which we have data for. We acknowledge the limitations in our current solution. For instance, the tool does not incorporate predictive analytics for global clean energy goals or any real-time updates. Additionally, while our design is optimized for desktop users, mobile compatibility is still in development, and these are areas we plan to address in future iterations. Our project isn't just a visualization tool, it's a call to action. It empowers users to understand the global energy landscape, identify gaps, and advocate for meaningful change. With further development, we aim to expand its features, incorporating real time data and predictive analytics to help nations plan for a sustainable future. We believe this tool has the potential to transform how we understand renewable energy adoption. It's not just about data, it's about driving collective action for a greener planet. Thank you for your attention. We hope you will support this project and join us in shaping a sustainable future. Together, we can make a difference.